Hello everyone. This video we are going to learn the bagging and random forest machine learning algorithm. Okay? First we'll learn what is bagging. Bagging is an ensemble technique in machine learning algorithm. Ensemble technique. That means bagging combines multiple machine learning algorithms. How it does? How it does? Consider training dataset. This is our training dataset. But I will train on three models. Consider I will train on three models. You can train on n number of models. But I will train on three models. Model 1, model 2 and model 3. Bagging will train your training data set on n number of models. I have considered, for example, three models. These three models will be, suppose my first model will be logistic regression. Second model, I will train the data set on naive Bayes. Third model, I will train my data set on decision tree. So this is bagging. So it will train multiple models. Train multiple models. And how this training is happening? How this training is happening? If you see here, taking place simultaneously, is training all the models at a time. This is known as parallel training. Parallel training. So bagging will train multiple models in parallel. This is important in bagging. And what about the output then? I have trained multiple models now. Each model will give different outputs. Output 1 is consider this as output 2 and this as output 3. Every model will give different outputs. So what will be the output of your bagging model? Combining all this model, how the bagging will predict the output will make the combination of prediction. Combination of prediction. Let me redraw. This is our, sorry. So this is our training data set and we have trained three models: logistic regression, naive Bayes and decision tree, and we have got the three outputs. Okay, now I want to test my model, so I will give the test data to check the prediction. So my model 1 will give an output, and model 2 will give some output, and model 3 will give another output. Suppose for classification task, we have trained our model on classification data, and the model predictions are: logistic regression has predicted for classification task as 1, model 2 has predicted as 0, and model 3 has predicted as 1. So what is our final output? Will be our final output. The bagging will combine the outputs for classification. Bagging will combine outputs for classification. It will use majority voting. For classification, it will use majority voting. Now let's see here. We have two outputs as 1 and one output as 0. So majority class here is 1, right? Majority is 1. So our final output will be 1 because we have done the majority voting case of classification. And what about it is a regression data? We are training our model on regression data. Let's consider one example here. Suppose our model is predicting salary based on some input features like department, experience, is predicting the salary. Is predicting the salary. This will be our continuous target variable. This is going to be an regression task. Suppose the salary predicted by model 1 will be 80k. Salary predicted by model 2 is 85k. Salary predicted by model 3 is 90k. So what will be the final prediction? So for regression task, the bagging algorithm will calculate the mean of outputs, output 1 plus output 2 plus output 3 divided by 3. So on. Output n divided. This will be n. So in our task, we have three outputs 80k, 85k, and 90k. So the final prediction will be 80 plus 85 plus 90 divided by 3. That will be 85k. So this is our salary predicted by bagging. So this is how the prediction will happen in bagging algorithm. And one more point you have to understand here is bootstrap aggregation. So our bagging will not only train the training data set on multiple models, not only train the training data set on multiple models, but it will also do the sampling of data set. Won't provide same sample to every model. It will do the sampling. Bootstrap aggregation means it will bagging will create many data sets. From original data. So how is it going to create many data sets from original data? By making random samples. By making random samples with replacement. I will explain you this with an example. Suppose this is our original data set. Okay, this is our original data of students. we have records A, B, C, D, and E. For the model 1, consider for the model 1, bagging will do the bootstrap aggregation and it will make the random samples with replacement. So what data it will give to the model 1 will be like A, B, C, D, E. See, B is repeated twice. The record, oh sorry, record B is repeated twice. So records will be repeated, but the sample size is same as original size. It has five records, and this is also having 5 records. So the sample size is same as original data. Sample size is equal to original data size. But the records are repeated. This is called samples with replacement. And for model 2, it will give the records, like A, B, D, E, D. Here D is repeated twice. And for model 3, it might give records such as A, C, D. Here A is repeated thrice, right? So this is how the bagging will do the bootstrap aggregation, that is making random samples with replacement. Is making random samples with replacement. So what happens here when bagging will do the random samples and train multiple models and get an final output? What is the advantage of doing all this? Bootstrap aggregation plus training multiple models. What is the advantage of all this? It will reduce overfitting of data. You can overcome the overfitting of data. You can handle the overfitting of data. This is the main advantage. Of bagging. That's why we should, for model accuracy is low, if you find overfitting, you can go for ensemble approach, that is bagging approach. And the famous and the popular machine learning algorithm in the bagging is random forest machine learning algorithm. Okay, it is similar to bagging, completely similar to bagging. I mean, it will do bootstrap aggregation. Random forest will do train multiple models. And it will also combine the prediction. Same way for classification, majority voting. For regression, it will do the mean. Everything is same in random forest machine learning algorithm. It is completely same to bagging, completely similar to bagging. But the difference here is the multiple models that it will train multiple models, but not the different models. All models are decision tree. All models will be decision tree models. It will not train the different models. Random forest will do the train the data only on the multiple decision tree models. And one more is, when training the multiple decision tree models, it will do the random feature selection. Random feature selection. So let's understand this. This is our training data. And what the random forest will do? It will train the model on multiple decision trees. This is decision tree 1, decision tree 2, decision tree 3, so on up to decision tree n. So it is training your data on multiple decision trees and making the prediction by combine prediction, right? I have mentioned here random feature selection. What it will do is, suppose I have a data like this. Our target variable is y, okay, and I have input variable as x1, x2, x3, x4 and up to x5. So this is our data. First it will do bootstrap aggregation, and when training the random forest will do random feature selection. So it will not provide all the features to every decision tree. What do I mean here? Decision tree 1 will get the data only x1, x2, x3 and y. And decision tree 2 will get the features x1, x3, x5 and y. Decision tree 3 will get the data x3, x2, x5 and y. See, we have total 5 features, but it is not providing all the 5 features. It is randomly selecting features. It is randomly selecting features to train each decision tree. So this is the difference between bagging and random forest. Random forest is an bagging machine learning algorithm. Random forest is bagging machine learning algorithm. It uses the bagging ensemble technique. Along with, in addition, train only decision tree models. Also perform random feature selection. Okay, I will draw a diagram for you which will give you a better understanding. Okay, so remember this diagram. If you want to explain random forest, if you want to revise random forest, so just remember this diagram. You can original data. Okay, this is our original data. bagging algorithm will do the bootstrap aggregation. Bootstrap aggregation, that is random sampling. That is what I said, random sampling with replacement. Bootstrap aggregation is random samples with replacement. After bootstrap aggregation, suppose we'll consider three decision trees: decision tree 1, decision tree 2, and decision tree 3. It will train multiple models of decision tree. On what features it will train the decision trees? Random features. Now it will do the combine prediction. How? For classification, majority voting. For regression, mean of outputs. And then it will give you the final prediction. Okay, so remember this diagram. This will explain you the bagging and random forest. Original data, you have given machine the original data, it will do the bootstrap aggregation, then it will train random samples with random features for each decision tree and combines the prediction. For classification it will be majority voting, and for regression it will be mean of outputs, and then give you the final prediction. This is random forest and bagging. Only bagging, the model will train on different machine learning algorithms, but for random forest only the decision trees. This diagram is important. If you remember this diagram, you can explain the random forest and bagging easily. Thank you. Thank you so much for watching my video.